right, let's talk about the types of member functions you could have in your class. I'm going to start with mutators, accessors, and private helpers. A mutator function is a function that changes or mutates member data. In other words, changes attributes. We also could call these setter functions, so you'll hear me say mutator and setter interchangeably. Here's an example of a setter function for the book class. A setter function will always be void, and it will always accept data, so it'll always have a parameter. The data type is going to be the exact same data type as the attribute that we're changing. So numPages is one of our attributes, and numPages is an int. The name of the function is important. A setter function is always going to start with the word set, and then have the name of the attribute using camel case. Of course, we're going to say that it belongs to the book class and have our scope resolution operator. So numPages is our attribute, and num is the data that was sent to this function. So this is going to set numPages to whatever was sent to this function. An accessor function is a function that gets or accesses member data, but doesn't change it. We can also call these getter functions. Here's an example of an accessor function. An accessor function will always have a return type that is the same data type as the attribute that you're returning. So numPages is an integer, so we're returning an integer. The name of the function is always going to start with get, and then have the name of the attribute using camel case. Also, you always want to make accessor functions constant functions, so that you ensure that you won't accidentally change the data in this function. Then you're going to return, and then the name of the attribute that you're returning. Private member functions are defined under the private access specifier. And if you define a member function as private, that means that it can only be called by another function in the class declaration. It is used only for internal processing by the class, not for use outside of the class. In other words, it's not going to be part of the user interface for the class. I've already shown you OOP.cpp, and I will show you Rectangle version 1, but I want to move on to talk about how these files are actually organized, because if you notice, this Rectangle version 1 is going to contain a Rectangle class, and we have a header file called rectangle.h, and we have a source file called rectangle.cpp, and then another source file called myprog.cpp. So the class declaration should be in a header file, and the header file should be named the exact same thing as the class name. This is called the class specification file. So for the rectangle class, we created rectangle.h. Then all the member function definitions should be in a source file that is also named the same thing as the class. So classname.cpp. And for our rectangle class, it's called rectangle.cpp. This is called our class implementation file. This file should include the class specification file. So in other words, at the top of rectangle.cpp, we will have #include, double quote, rectangle.h in double quote. Programs that use the class must also have a #include and include the class specification file, and be compiled and linked with the member function definitions source file. There's a couple other member functions. One of them is called a constructor. A constructor is very different from the other member functions I've already talked about. A constructor is a member function that is automatically called when the object is created. So you don't actually have a function call statement. The purpose is to construct an object. I would like you to think of it as an initialization routine. The constructor function name is going to be the exact same name as the class. Also, constructors are not allowed to have a return type, not even void. There's two types of constructors. A default constructor is a constructor that takes no arguments. In other words, it has an empty parameter list. If you write a class with no constructor at all, C++ will write a default constructor for you, one that does nothing. Creating an instance or object of a class with no arguments calls the default constructor. So for the rectangle class, if I create a rectangle object like this in my outside code, it's going to automatically call the default constructor. Now the other type of constructor is called an overloaded constructor. And it's going to be a constructor that does take arguments and has a parameter list. So this is an example of a function prototype of a constructor of the rectangle class. Notice that it does contain parameters, double and double. In the function definition for the rectangle overloaded constructor, notice that there's no return type, so you don't see void or anything else before we put the class name, scope resolution operator, name of the constructor, which is the same thing as the class. Then we have two doubles. And what this does, I told you to think of it like an initialization routine. Width and length are attributes in this class. So this is going to set width to whatever was sent to this function in this W parameter. And length is going to be set to len. Whenever I'm actually creating an object and I want the overloaded constructor to be called, this is what it would look like. I create a rectangle object, I'm calling the object R, and I'm sending two arguments, 10 and 5. So this would call the overloaded constructor. I'm now going to show you all the different example programs that I've kind of skipped over for a second. So we're going to look at Rectangle version 1, Rectangle version 2, and Cell version 1. Each of these are organized in their own folders because they have multiple files. So we're going to look at Rectangle version 1 first. So I'm going to open VS Code in the folder Rectangle version 1. Oops. Did that actually work? It did. No, it opened up the parent folder. Okay, I accidentally forgot to put code space dot to make it open in this current directory. There we go. Let's look at the header file first. So remember, this is called your specification file for the rectangle class. Since it's a header file, you still have to have your include guards. Then any libraries that this class might use, you would include up at the top. Here's my rectangle class declaration. So class rectangle, beginning curly brace, all my private attributes, which are just width and length, both doubles, and then my public member functions, which include my setters, or in other words, mutators, and my getters, which are also called accessors. So this is my function prototypes. So now let's open up the class implementation file, which is rectangle.cpp. I have to include rectangle.h, and then I have all my function definitions: set width, set length, get width, and get length. Notice that we're going to have setter and getter functions for each attribute. Make sure that you say it belongs to the rectangle class and that you have your scope resolution operator before the name of the function. Now, we also have a function called getArea, which is not technically an accessor function. GetArea doesn't access or return a single attribute, but it does return the multiplication of the two attributes. And it is a public member function. Now let's look at some outside code. So outside code is basically any code that uses or that creates an object from a class. And you just have to make sure you include the class at the top. So #include rectangle.h. Notice that I don't have to include the source file, the implementation file. I only have to include the class specification files, which is the header file. In this program, I create a single rectangle called box. And then I also have these doubles rect width and rect length. I ask the user to enter in, actually first I print out the length and width by calling the getter functions. Then I ask the user to read in the width and the length, or to type in the width and the length. I read that in, and then I call the setter functions to set the width to that width and set the length to that length. Then I call all the accessor functions plus the getArea function in order to print out the width, length, and then the area. So let's compile and run this program. Oh, I already have a command prompt open. So on Windows, one thing that you can do, instead of listing out the source files, which is one way to do this, I could list out rectangle.cpp and space myprog.cpp. So I'm going to do this first to show you that it does work. And if it compiles, which it should, it will create an executable file named A. And at the beginning of the program, the length is this crazy number and the width is this crazy number. That's because we haven't called the setter functions, and we also don't have a constructor set up for the rectangle class. So now let's enter in the width 7, length 2. And then it says here's the rectangle's data. Width is 7, length is 2, area is 14. Okay, so what I wanted to show you though is that I could also compile these files together by doing g++ star.cpp. This is going to grab all the source files in the current directory and compile them together and create the executable file. So it's just a shortcut way to compile a program that has multiple source files. All right, let's take a look at Rectangle version 2 and see the differences. So I'm going to close VS Code because I'm going to reopen it, but in the directory Rectangle version 2. All right, let's look at the class specification file first, rectangle.h. Rectangle.h has our class declaration in it, our attributes. This time you see it has a default constructor and an overloaded constructor. Notice there's no return types for the function prototypes. Default constructor will not have any parameters, overloaded constructor will. And then let's go to rectangle.cpp so you can see these constructors. First, we make sure that we include rectangle.h. The default constructor, all it does is prints out, hi, you're creating a new rectangle object. Then the overloaded constructor, it prints out, hi, I'm in the constructor that has parameters, and it actually initializes width to W, length to len. Now normally your default constructor doesn't just have a cout statement. Normally we would set width to 0 and length to 0. Basically just initializing your attributes to 0, or if it was a string, initializing it to an empty string. So I'm going to add that to this. And then I have all my other functions, which I've already talked about, except these examples show some validation, like if W is less than 0, a negative value, it's not going to let you do that, and it's going to actually exit the program. I usually don't like to use this, but I pulled this example from a textbook, and it already had that in there. So this program only has 2 setter functions. It looks like it does not have, oh, aha, it does have getter functions or accessor functions. It's just that I define them differently. I define them inline. What that means is that the entire function definition is actually in the class declaration, so inside of the class. And if you do that, notice that you do not have to put the name of the class before the name of the function. So the entire function definition is inside the class declaration, and that's why it wasn't in the rectangle.cpp file. Now let's look at the program, which we're going to run in a second. We do several things in this program. We first create a rectangle object called my mom and dad's crib. Note that as soon as we create the object, the default constructor will be created, which sets the width and the length for my mom and dad's crib to 0 and prints out that statement, "Hi, you're creating a new rectangle object." Then I set the width and the length of my mom and dad's crib to certain values, 20 and 25. And then I call the getArea function. So it's going to print out the area of 20 times 25. Then I get the width of a house and the length of a house from the user. And after I get the width and the length, I then create another rectangle object called house. And this time I'm calling the overloaded constructor because I'm sending that width and the length to the overloaded constructor function. It is then going to call that function automatically. It's going to print out I'm in the constructor that has parameters, setting the width and length to whatever the user entered in. Then it will call the getter functions on this second house object or rectangle object. So I'm going to compile this code and run it. Hi, you're creating a new rectangle object. That's when I created my mom and dad's crib. And then it calls the getArea function after setting both the length and the width with the setter or mutator functions, which is 500. Now it's allowing the user to enter in a width 8 and a length 20. And then it creates another rectangle object calling the overloaded constructor. And so it prints out, "Hi, I'm in the constructor that has parameters." And then we call the 3 getter functions, or actually the 2 getter functions that gets the width and gets the length, and then we call the getArea function. Okay, there's also that other example program, the Sail version 1, which you can take a look at. It's similar to the Rectangle version 2. First, I'm going to talk about the this implicit parameter. So the this implicit parameter you can use whenever you want to say this particular thing, whether it be a attribute or a member function, that this belongs to the class. So in this example right here, this is Sail version 2. I have my attributes item cost and tax rate. And then I have an overloaded constructor called Sail because my class is called Sail. And I say this arrow item cost. And so what this is doing is saying item cost is an attribute in this class. And I'm setting the item cost to cost and setting tax rate to rate. All this is doing is making the code a bit more readable, because anytime you see this, you know that whatever it's in front of is either a data member or a function member that belongs to this class. The last member function that I want to introduce to you is the destructor member function. It is opposite from the constructor, but it has some similarities. The destructor is also automatically called, but it's called when the object is destroyed. The name of the destructor is also going to be the name of the class, except it's going to have a tilde in front. So it's going to be tilde rectangle for the destructor for the rectangle class. The destructor, just like the constructor, has no return type. But unlike the constructor, it also takes no arguments, which means you can only have one destructor per class and it can't be overloaded. If a constructor allocates dynamic memory, the destructor should release it. And really, this is the only good purpose that I can think of for a destructor, is if you're dynamically allocating anything in your class, the destructor is the perfect place to release that memory. So let's take a look at Rectangle version 3. I'm going to close this out and close that out. Okay, I'm in the folder for Rectangle version 3. Opening VS Code in this directory. My class specification file for the rectangle class in this third version is going to have everything you've seen in the other rectangle versions, except in addition to the constructors, we have our destructor. So notice it's named the same thing as the class and the constructors, except it has a tilde in front. And it's not going to contain any arguments here. It can't accept any parameters and has no return type. And then in the rectangle.cpp file, here's my default constructor, my overloaded constructor, and here's my destructor. So we say it belongs to the rectangle class, scope resolution operator. Whoops. I didn't mean to do that. There we go. Then the tilde, the name of the class, because that's the name of our destructor. And all this destructor does is say goodbye. So I'm going to show you this program. This program creates several rectangles, including dynamically allocating a rectangle. Okay, so I haven't shown pointers to objects, but it works a whole lot like pointers to structures. So I created a pointer, which is just a variable that can hold a memory address. This particular pointer can hold the memory address of a rectangle. Then I dynamically allocated a new rectangle, and this one calls the overloaded constructor, setting the width to 4.5 and length to 9.7. Then I call the getArea function of this new rectangle I just created. Notice that instead of the dot operator, I'm using the pointer operator, and that's because this is a pointer. And then I'm deleting this rectangle. Now, there's going to be several things printed out here besides just dynamically allocated rectangle area. And I'm going to go ahead and compile and run this so I can point that out. Okay. So first, it says dynamically allocated rectangle area is 43.65. I thought that my constructor prints out something, but I guess this version, nope, I was wrong. So this overloaded constructor doesn't actually print out anything, but I thought it did. So there's nothing printed when the constructor is called, but then it does print out this line, dynamically allocated rectangle area, 43.65. Then it prints out goodbye. And that's because the destructor is called right here whenever I delete the object. Now, any object that's created normally, like this one right here, it's not going to be removed or deleted until return 0. Same thing for this rectangle object that I create. It's not going to be deleted until return 0. So we're going to see 2 goodbye statements printed out to the screen at the end of this program. So I'm going to enter in some numbers here for width of the house, length of the house, and then you see goodbye, goodbye, because I create 2 more rectangle objects. One right here and one right here. So you now have seen all the different main member functions that you would have in a class, including your accessor functions, mutator functions, any private helper functions, constructors, and destructors.